Have you ever wondered what really separates a good programmer from a truly great one? Well, I'm here to tell you, it's not some kind of magic. We're about to peel back the curtain and look at a way of thinking that can take a messy, brute force idea and turn it into something absolutely brilliant. So, if you're a programmer, you know the feeling. You walk into a technical interview and they hit you with these puzzles that just seem designed to make you sweat. But here's the secret. They're not really testing if you've memorized 100 different algorithms. They're trying to figure out something way more fundamental. Right, what they actually want to see is how your brain works. Can you take a big, messy problem and break it down into smaller, manageable pieces? Can you talk through your thought process? And, can you actually turn your ideas into code that works? It's all about the problem-solving journey. Okay, so to really get a feel for this process, we're going to tackle a classic puzzle together. Now, on the surface, it looks pretty simple, but trust me, it is the perfect way to see how we can level up from just a decent idea to a really great one. So here's the setup. Imagine Alice lays out a bunch of cards, all face down. The only thing our friend Bob knows is that the numbers on these cards are sorted from the highest all the way down to the lowest. His mission, should he choose to accept it, is to find a specific card, let's say the number 7, by flipping over the absolute fewest cards possible. So, how should he do it? Now, your gut reaction might just be to start flipping cards randomly, or maybe to jump straight into writing code. But the pros? They have a system. They use a kind of blueprint to attack problems like this, one that pretty much guarantees they'll land on the best, most efficient solution. And this, right here, is that blueprint. It's a 6-step method that takes you all the way from just wrapping your head around the problem to actually perfecting the solution. Honestly, this process is the real secret weapon. So let's follow the blueprint. We're going to jump to step 3. Find a solution that works. It doesn't have to be pretty, it doesn't have to be fast, it just has to be correct. This is usually the most obvious, straightforward thing that pops into your head first. In the programming world, we have a name for this. It's called the brute force solution. It's not fancy, it's not elegant. It just plows through every single possibility one by one until it bumps into the right answer. And it's almost always the easiest thing to think of, which makes it a fantastic starting point. So for our card game, the brute force strategy is super simple. Bob just starts at one end of the row and flips over every single card in order until, pop, he finds the one he's looking for. We call this a linear search. Easy, right? But is it any good? And this is exactly where our simple little plan hits a gigantic brick wall. I mean, if there are 10 cards, sure, no problem. But what if Alice puts out 10 million cards? If the card Bob's looking for is way at the other end, he's going to be flipping cards for a very, very long time. This solution just does not scale. To talk about this inefficiency, programmers use a cool tool called Big O notation. For our linear search, we'd say its complexity is O of n, where n is just the number of cards. All that really means is, in the worst-case scenario, the time it takes to find the card grows in a straight line with the number of cards. More cards, more time. Simple as that. Okay, back to our blueprint. Step 5. Analyze what we've got and find the weak spots. We know our linear search is inefficient. But why? Well, it's because we're ignoring a critical piece of the puzzle. And there it is. That's the fatal flaw in our thinking. We're just plodding along one card at a time, completely and totally ignoring the biggest clue Alice gave us right from the start.
This is the pivot point. This is the aha moment. The cards are sorted. That one fact changes absolutely everything. Instead of checking every single card, we can be so much smarter. So how can Bob use this to his advantage?
Check this out. It's a brilliant new strategy. Instead of starting at the edge, Bob goes straight to the middle card and flips it over. If that number is, say, too low, he instantly knows his card has to be in the first half. If it's too high, it has to be in the second. In one single move, he just eliminated half of the cards from his search. Then he just does the same thing again on the smaller leftover half. This amazing trick is called binary search. So now we have two strategies, the simple, kind of slow linear search and the super clever binary search. Just how much of a difference does this smarter way of thinking actually make? Well, get ready because the numbers are pretty mind-blowing. So on one hand, you've got linear search, chugging along one by one, with that O of n complexity. On the other hand, you've got binary search, which is just chopping the problem in half over and over. Its complexity is O of log n, which, trust me, is ridiculously better.
Let's see what that looks like with real numbers.
Okay, let's go back to that massive problem. Alice lays out 10 million cards, and the one Bob needs is hiding way down at the very end. Using our brute force linear search, checking almost 10 million cards would take about 1.2 seconds. I mean, in the world of computers, that's a pretty noticeable delay. You'd feel that. But with binary search, by just repeatedly cutting the search area in half, it finds that exact same card in about 0.02 milliseconds. That is so fast, it's basically instantaneous. You can't even blink that fast. I mean, just look at that difference on the chart. It's almost comical. Our optimized binary search isn't just a little bit faster. It is over 55,000 times faster than the first idea we had. That's the incredible power of finding the right way to think about a problem. But listen, the point of this whole exercise wasn't just to teach you a cool trick called binary search. The algorithm itself is the result, but the real prize, the thing that the best programmers carry with them to every single new problem, is something else entirely. And that is the absolute key takeaway. The goal was never to just memorize an algorithm. It's about making this 6-step blueprint a part of how you think. This is the framework that helps you find a simple solution, see its flaws, and then systematically build your way to a brilliant one. This process is how you discover amazing solutions all on your own. This way of thinking isn't just for coding interviews, right? It's a powerful tool for breaking down any complex problem you might face. So the only real question left is, what problem are you going to solve with it?